Metallic Biomaterials, qualified in the Sendai lab. Liu Huihong, Tohoku University, Sendai, Japan.
Scoliosis is one spine disease, as shown in the figure. In the world, around 3 in 1,000 persons have serious scoliosis which need a medical treatment, including the surgery. In the surgery, the distorted spine is corrected by this implant rod. In this case, an ideal rod with 4 key properties is needed. Firstly, in the operation, the surgeon must bend the rod to conform to this spine curve in a really small space in the patient's back. In this case, the high stiffness rod is required because it shows a small recovery when surgeon bends and releases the rod, and this means the rod is more controllable. However, if the high stiffness rod is fixed on the bone, the stress will go through along the rod, and this will make bone sick and weak. While in the case of the low stiffness rod, the stress will go through along the rod and the bone at the same times, and this makes the bone healthy and strong. In this case, the low stiffness rod is required. Thirdly, the high strength rod is required because it can provide enough force to keep the bone straight. Fourthly, the flexible rod is also required because it can avoid the fracture when surgeon needs to bend the rod to a large degree. Generally, these 4 conflicting properties are really difficult to be incorporated in one material at the same time, and this is the wall we want to break. For breaking the wall, a novel titanium alloy was developed based on this diagram. The diagram tells us how to choose the best composition with the most suitable electronic parameters called BO and MD, which is expected to have these 4 conflicting properties. After much experimentation, the novel titanium nichromum 0.2 oxygen alloy was developed finally. Like a magic wand, this alloy can achieve a high stiffness in the deformed parts and keep a low stiffness in the non-deformed parts. Further, it also has a high strength and a good flexibility. With these 4 conflicting properties in one material, this alloy will make the surgery easier and more controllable. Millions of patients will receive the safer and more effective scoliosis surgery. As a result, the patients can enjoy the painless and healthy lives after surgery. Ladies and gentlemen, this alloy will definitely break the wall of metallic biomaterials. Thank you.
Thank you very much. Next one question.
What about the structure, the role of the structure? You talk about material.
Yes.
What about the role of the structure? Even changing the structure, you can modify the property that you mentioned.
Structure, you mean the crystal structure or the shape?
The macroscopic structure of your rod.
Okay.
You can make it taper, for example, or other things.
Okay, the structure, the base structure is the, the cubic standard structures. This.
Okay. Thank you. Next one, please.